Broadcast is now starting. All attendees are in listen-only mode.
Well, hello there, good afternoon, and a very warm welcome and thank you to everybody joining us this afternoon for this British Coffee Association webinar in conversation with Professor Claudio Avignone-Rossa, who's a Professor of Systems Microbiology at the University of Surrey. As always with these webinars, we want you to be a part of the discussion and we welcome your questions throughout. So do feel free to put your questions, send them in, and I'll put them to Claudio as we go. Now, we got in touch with Professor Avignone-Rossa when we heard about his groundbreaking research because it involved coffee. More specifically, it involved coffee waste, and his work has provided a way to mitigate the pollution it can cause to water and the environment in coffee-growing countries, and he's also found a way of generating electricity as well. So, of course, we wanted to hear more, and we hope that you do too. And thankfully, Professor Claudio Avignone-Rossa has given us his time today to tell us more about it. So, Claudio, I wonder if we can start with you talking about what the problem is, why coffee production can be harmful to the environment in some cases.
Well, thank you, Katrina, and thank you for the invitation, of course. Yeah, the main problem is that from the coffee bean, from the coffee fruit, we only get something like 20% of the mass there, and the rest is organic matter that is just thrown away. And that organic matter, of course, is thrown to rivers, or it finds its way to rivers or to the ground, and it causes pollution. It causes the growth of undesired microorganisms, so smell and some possibly toxic compounds, or at least polluting compounds, and it's a lot of energy contained in that organic matter. So, in collaboration with my colleague Lina Agudelo at the University of Antioquia in Medellin, in Colombia, we decided to test if it was possible to use that organic matter in the coffee waste to as a food stock, as a feedstock for our system called a microbial fuel cell. And maybe I need to explain what a microbial fuel cell is. Microbial fuel cell is comparable to a chemical fuel cell, but in this case, the catalyst obtaining electrons from fuels are microorganisms, and some microorganisms can extract these electrons by using the nutrients and transfer the electrons to an electrode, to an anode, and if you connect the anode to a cathode, electrons circulate and you get electricity. So the idea was to use. Well, it's very. It's simple and it's complex. It's simple because it happens spontaneously if you give the right conditions, but it's difficult because you need to jump over too many barriers and technical and operational barriers.
What was it about this problem then, though, that made you? Why did you get involved in this? Why did you decide specifically to look at coffee, and also why in Colombia?
Yeah, well, I started working with microbial fuel cells in 2005, 2006, I think, using or trying to develop a system to produce electricity using single species, easy to control, and using very simple feedstocks. But then you start thinking, well, that's very nice, and you can produce a lot of electricity, or a lot. You can produce some electricity, but what's the use of using pure compounds that can be used for something else? So we started working with wastewater from industries, from the chemical industry or from food industries that contain much higher amounts of compounds. And we started using microbial communities rather than one single species, using a community normally obtained from the environment. That worked well, reasonably well. We used the system for residue from the bioethanol production, residue from other industries, even from domestic wastewater. And then my colleague Lina, she was interested in joining my lab for a while with a Newton Fund grant. And she said, well, I'm interested in bioremediation, bioprocessing. And I said, well, why not using what is in excess in Colombia, which is a coffee waste, with this system? So it was a proof of concept, if you want. And we knew that the polluting, the pollution caused by the coffee is very large. So we said, well, why not? And there are several different compounds in coffee production that remain like that. They are not degraded by, or not easily degraded by microbes in the environment.
Mm.
So that was a combination of, well, having the right tool and having the right feedstock, so we can put that together.
And in the most unscientific way possible, I suppose, can you tell us how it actually works? So how do you take the water, and what are you doing, or the waste products, and what are you doing with that to generate electricity?
Well, the water, I mean, this is primary production of coffee, right? This is what happened in the farm. It's not the production of roast coffee or instant coffee. And I presume 95% of the coffee producers in the world are small farmers, family enterprises that they cannot afford having or constructing a system for wastewater treatment.
Mm-hmm.
So the farm normally is a very simple system in which there are no pumps, or because the liquid is moved by gravity. So you discharge the beans on the top, and then they find their way to the bottom, and the process happens in between. There is a fermentation of the beans. So when the coffee grain matures, and then there's a wash up system, and then there's a drying system. So every step has a lot of waste being thrown away. So as I said, this waste can be used as a feedstock for the microorganisms. Now, microbes in the world, in the environment, there are many different species. They can do many different things. Some of them are only degrading large molecules, proteins, or big sugar molecules, or that are normally difficult to degrade. Some others are more specific. They can use little molecules produced by the degradation of the large molecules. So those little molecules will be oxidized, will be converted, broken down by the microbes, and the microbes will use that as a source of energy. And the source of energy is normally transfer of electrons. Okay. So in our cells, we use oxygen to capture the electrons released in our metabolism, in our biological processes. In the particular case of microbial production of electricity, instead of giving oxygen to these microbes, we give them an electrode. So a piece of some material that is able to capture electrons based on physicochemical properties, right? So those electrons are transported from the microbes to the electrode. And that electrode then, as I said before, if you connect it to another electrode, you make the electron circulate, and that circulation of electrons is an electric current.
Okay.
So essentially, any bacteria, well, I don't know if any, but many bacteria can use an electrode as an acceptor of electrons. Meaning that in the environment, you will find a wide range, a very large number of species that can do that. So what we did is we went to the sediment of a river, we went to an anaerobic digestion plant, we went to the soil and collected different types of microbial communities. And we put them in our reactors, and we saw what happened. And the most important thing is that you generate a little bit of electricity, but you generate a very large decrease in the organic content of the waste. So what started as a, well, potential production of electricity ended up as a very good system to reduce the organic matter. And the amount of electricity produced is little, but you can use it for something, right? So we did some, our proof of concept was to show that we could do that. And then we were awarded the Newton Prize, and that was to test the system in the farms in Colombia, using materials that are available locally. So instead of using nice stainless steel, beautiful perspex, fantastic connectors, we use ceramic from potteries in Colombia. We use pieces of some kind of bamboo like plants that grow there, that they have the right shape. We use ceramic materials as membranes. So we use things that could be recycled or repurposed or reused to build our system. So that was during the COVID, so that was quite a complex time, a difficult time. But the colleagues there were able to construct this little device that produces electricity and degrades the organic matter at quite a considerable amount. Something like 70% of the organic matter can be reduced. So we are releasing the water after the process. The water contains 70% less organic matter than the original, which is very, very impressive.
So that's two real huge benefits then. There's the reduction of potential pollutants into into the environment and the water systems, but then also this sort of byproduct, if you like, of production of electricity. How much electricity are we talking? Like, you know, what could you do with it? What could it run?
Okay, in the lab we can obtain not much. It's milliwatts. I mean, it's difficult to explain or to express because differently to other systems, the amount of electricity is not calculated by the volume of the system, but by the surface area of the electrode. Right. So per square meter we can obtain around in the order of milliwatts. So it's not much. So people sometimes are quite, well, they laugh at us because they say, well, that's nothing. But you can harvest that electricity. And it's quite easy, quite cheap to harvest the electricity. So if you multiply the number of these units, these fuel cells, right, you can increase the area, the surface area, by increasing the number of fuel cells, and you can harvest the electricity. So we know we did some calculations and a little bit of experimental work, we can harvest electricity, we can light, I don't know, the room where, I don't know, one of the washing pools is, right? So you possibly you're not going to light up the whole house, but you can put an LED in a room. So you can help the farmer by, well, producing electricity to light up the system where the environment where the system is. At the moment, we are working with other colleagues using other type of projects to create or to build a good system for harvesting electricity. But this is still being worked out.
It sounds like sort of true circularity as well, if you're talking about using fuel cells that are made out of, you know, not particularly expensive or produced for that purpose items. You're really using things that are already found there to then, you know, sort of complete the circle, really. And I know that there's a Nestle factory, I think, or a plant near Newcastle where they use anaerobic digestion and they are generating electricity, but that's, I think, there's a special purpose-built thing there, whereas it sounds like you are able to harness what's around to complete that sort of, you know, circular idea.
Well, our idea is, I'm starting a project with, I mean, this is another type of coffee waste. I presume it's a coffee waste, the waste produced when instant coffee is produced, I guess. I know that most of the coffee waste is either used as in anaerobic digesters for production of methane, and some is used as a fertilizer, or is disposed of in landfill. Our idea is to try to extract material from the coffee, from that solid coffee coming from the instant coffee production. So we are starting a project in October in which we are going to use our system to obtain a bit of electricity, but also to see if we can convert part of the compounds present in the coffee into something of use, some platform chemicals or biochemicals, rather than using it only for anaerobic digestion.
Mm-hmm.
So from that coffee, you can obtain many different compounds, including nanocellulose. You can use some of the lignocellulose to be converted microbiologically in something else. So, but this is something we're going to start in October.
Mm-hmm.
What you said about the circular economy or the circular cycle there is that, yes, we believe we can form part of the circular cycle there. You know,
Mm-hmm.
the circular, the life cycle of coffee. Of course, this needs to be organized from top. I mean, you need to give the farmers some incentives to use this.
Mm.
Luckily, we have people in the farms that are very much interested in working with us. They are interested in discussing with us what they can do. They even can have offered a small plot to set up our system. So we are, and this is what we're going to discuss in my visit in July with the people in Colombia. I know that there are colleagues here in the UK working with coffee waste in the University of York, and they did similar approach to ours, but without the electricity part. So they were trying to extract material from the coffee waste.
Mm.
So we suppose we can combine forces to do something with them. I know that there are companies using the waste to try to produce some value-added materials, and I would like to have a chat with them. And I know there are several coffee companies or companies interested in coffee. They would be interested in having a chat with us. So I think we can put together a very nice scheme to work in coordination. Yeah.
In terms of the sort of scalability of this, then you said that if you increase the surface area of fuel cells, you can increase the amount of energy production and therefore electricity harvested. Where do you see this going? Does this have potential to perhaps even lend itself to sort of self-sustainability for the farmers at some stage?
That's the idea, Katrina. We would like to have a system where we can produce enough electricity to, I don't know, to move a pump or to light the whole house, the whole farm, but that needs time and money to build the system. But once the system is built, as I said, I mean, one fuel cell in our lab costs something like 800 pounds, right?
Mm-hmm.
That is not translatable because it's only a small volume fuel cell. What we want to do is be able to build a whole battery of fuel cells with much less money, which is feasible. And as I said, we can use locally available materials, we can recycle stuff, etc. So that is feasible, that is possible, and we know that it can be done. So that's where we are now trying to work on.
Yeah. You said you chose Colombia because it's the third largest coffee producing country in the world, and also that because of the nature of the scale that the family farmers are using, it's all very small scale and that they don't have the money for water treatment plants and stuff. Do you see this being something that could happen all over the world in coffee producing countries, regardless of whether they have the money or not? Is this a more effective way of treating the water, the wastewater, and then also potential energy production?
Yes, I'm sure. I know that colleagues from other coffee producing countries are interested in this. They have been in touch with us, but COVID came and broke everything. all the lines of communication were interrupted, but we are in contact with them. Yes, because the system is not difficult, and you can train people to build a system there, and that's it. The only thing you need is to train a person. And the good thing of this cheap system is that if one is not working, you just take it away and put another one. You don't need technical assistance or mechanical people going there and fixing. So part of the idea of this Newton project was not only to build the system, to develop, but also to train the farmer, to train people so you will empower the person there. And we also know that especially the small farmers, they are very concerned about the pollution of the water, the pollution of the fields. They don't want that, but they are, in a way, they are forced to dispose of the waste in those places. But so it's a very good system to show that, well, you can work in an environmentally friendly manner.
Mm-hmm.
We were contacted by larger farmers, and they wanted to build a system, but it was not easy to see why they wanted to do that, because they had already a wastewater treatment plant, etc. So that's our next step: try to figure out if the larger farmer can also participate in this type of project. Yeah.
And is that what you're going to be doing in July? You mentioned that you're going to be starting a new part of the research in July in Colombia. Tell us about that.
Yeah, well, what we want to do in July is first try to go and have a chat with all the farmers that we spoke earlier. Some of them, as I said, they offered a piece of plot to set up our system. They are very much interested in that. We are going to have a chat with the cooperative of coffee producers, because they were interested in possibly supporting us, but they wanted something more advanced at the moment. So we cannot offer that yet. So we would like to see if we can work with them, to develop a larger system, or at least a working system. We still need to confirm the possibility of setting up a system, let's say that is reliable. And there are several operational issues that we need to solve. One is the large content of solids. It conspires against the proper functioning of the system. So that's a little bit of a problem that we need to solve. But we cannot do that if we are not there. So that's what we're going to be doing in July, with the Colombian colleagues. The project with the solid coffee waste is going to be running here in the UK, in my lab, and that is with the ground coffee waste from retailers or from, I don't know. We hope that the producers of instant coffee would be interested in joining us. Initially, we are going to be working with small coffee retailers.
That's what I was going to ask as well, actually, given that obviously a lot of our audience for this webinar, they all work in coffee, given that we're a British Coffee Association and we are representing those who work across the coffee supply chain in the UK. And what do you think, or how can how can they get involved in this? What would be an ideal scenario in terms of, because obviously environmental issues, sustainability, circularity, all these things are at the forefront of many coffee companies' minds now. This going forward, they want to make sure that coffee is sustainable and that it's done in the best way without harm to the environment, and while still providing a good living for the farmers, etc. So do you see a way of this being able to work hand in hand with coffee companies?
Yeah, okay. In our university, there are 2 or 3 coffee shops, right? And they produce something like, if I remember correctly, 60 kilos or 70 kilos of coffee waste per week, I guess. And they are just throwing it away. So we spoke with them, and they are some of them are very well known coffee chains. And the manager there said, well, yeah, we would be interested in giving you our waste, and we would be interested in helping you to do something. But this is going to be very local, and possibly as a curiosity rather than something interesting. But that will help us to show that we can do things more interesting than that, right?
Yeah.
So we guess that if we can present a proof of concept using solid waste, and we can show that it's useful, and not only producing electricity but reducing as I said, the organic load in the waste, in the ground coffee waste, that could help other producers or other retailers or other chains to convince them that you can do things with that.
Mm-hmm.
I'm not sure at the moment we will be able to run the fridges or power the fridges with the electricity, or I don't know, but we can possibly light some displays and put some lighting there, and yeah, I'm sure we can do that.
We've had a question in from our audience asking if there's an estimate of the capital cost for setting up a system like this at a processing plant at a cooperative site.
The short answer is no. I haven't calculated that. A more educated guess would be, if you can work with recycled materials, with cheap systems that do not require much infrastructure, I think you can build one system with possibly a few £1,000 in the farm. I'm talking about the farm. Mm-hmm. In a coffee shop, I suppose you need a bit more hygiene aspects to consider, and a bit more clean systems that could be a little bit more expensive. But using, I don't know, plastics and using systems that are not really complex to work with, I think you can set up a system for less than £10,000, I guess. The most expensive bit would be if you want to do it using, say, carbon cloth with a typical material for electrodes, etc. That could be a bit more expensive than using a ceramic. But in general, I think you can build a system, with 10,000, something like that. The next question, I suppose, is how much electricity you can get, and the answer to that is, well, it depends. But I suppose you can get something like in the order of milliwatts per square meter at the moment.
And we're talking about different ends of when you mentioned coffee shop waste there, that's kind of two different ends of the production system, isn't it? Because the research that you've done, for which you won the Newton Prize, is about the wastewater produced at the very beginning of the the process, and then obviously the coffee grounds from a coffee shop is at the very end. And I know that there are some companies, we've spoken to BioBean in the past, who take grounds, used grounds, and turn it into fuel in a different sense, but burnable fuel to create coffee logs. So are you saying that you can also take those coffee grounds from a coffee shop and generate the electricity?
Exactly. That's what we think. I know some of the companies are just burning or trying to use the ground coffee waste as some fuel for your log burner or something like that, which is reasonable, but the energy there is just dissipated as heat, right? Which is not bad, and because coffee is a natural product, is carbon neutral, which is fantastic. What we say is, well, you can also do something else. You can produce electricity with that, or you can try to extract interesting molecules from that coffee, from that waste. There are, I think in calculation is there are more than 2,000 or 3,000 different compounds produced when you roast the coffee, when you heat the coffee, when you produce the cup, So those compounds, okay, they are at low concentrations, but you can extract those small concentration, small compounds that are at low concentration. You can extract them and concentrate that. That's what we would like to do with the project starting in October. I don't think these two things are mutually exclusive. I presume what we can do is combine and extract as much as you can from the coffee and then give it to the guys burning the logs or whatever they call it. And as I said, I think this is all part of this circular economy aspect, right? The good idea would be at the end you have something that is not polluting, and you can put it in your anaerobic digester, right? Can obtain methane, something like that. So that's our idea. We are not claiming that we can obtain kilowatts of energy or electricity and tons of compounds. We are claiming that our system can be introduced in an integrated system for treatment of coffee waste.
Yeah, we've had another question from one of our attendees, and they're asking, would it be possible to add additional filtration to allow water to be reused, or does that water need to return to the land, that wastewater?
Yeah, the problem with filtration is that the filters clog very quickly. I'm reluctant to do this. Can I show a picture?
Yeah, of course you can.
Reluctant because technically I know it's going to be a problem. You know what I mean? But let me see if I can find. Can you see that? Can you see?
Yeah.
Yeah. Okay. What you see there? I hope you're seeing what I want you to see. This is a slide with a very nasty looking material, right?
Yeah, I was going to say, to be honest, I don't know what that is I'm looking at, but I can see something.
Okay. Okay, this nasty looking material is what it remains after the process.
Okay.
Right? So this square thing you see there is the body of the fuel cells that has been disassembled. And that material, that sticky, dirty material, is what the person is asking. That is what needs to be filtered, right?
Okay.
So imagine that a filter will clog in days, something like that. So it's really, really difficult to clean. So filtering water is okay if the amount of solids is not that large, right? If you have too many solids, filtering is normally not very efficient. What you need to do is settle the material down, which is possibly better. The problem is, I stopped sharing that.
What was the
The
one on
problem
the
is,
right?
it's another one. There were two different.
Same thing. Oh, okay.
Yeah. So so when this was in Colombia. When my colleagues opened that, they saw that and said, "Oh no, what's this?" And because they didn't expect that amount of solids to be deposited. These solids are polysaccharides, the mucilage that comes surrounding the beans in the fruit, the coffee fruit. So this is what we need to clean up. And the liquid that you could see in the center, that liquid is what contains soluble material, and that is what the microbes use to extract the electricity. So these are the operational problems we need to solve. Coming back to the question, yeah, you can filter, but you will get the filters clogged. So what people normally do is they put in settling chambers, so vessels, so all the solids will go down, but then you need to get rid of those solids. So the water will be cleaner, but the solids will be thrown away to the field with rotting and smells.
Yeah. And what happens at the moment then with that? Is that just going back into the rivers and stuff?
It goes to the ground and to water, and the same solid that you saw there, they normally, if you throw it to a river, they form a film in the river, and it prevents water or the ground to be, it becomes impermeable, right?
Yeah.
So it causes a serious problem. It's lack of oxygenation in the river, etc., etc. So you kill the fish. It's a serious issue. And if you have, I don't know, 100 farms near a river, then that river is collecting all the dirty water there.
Yes.
So it complicates things.
And your procedure is currently removing 70% of that then, of those?
It removes the 70% of the organic matter, yes. So the water coming in, you're forcing me to show another slide.
No, it's good for illustration because
No, that's fine. That's perfectly fine. Yeah. So this is, can you see that?
Yes, yep.
Yeah, okay. So that is the water coming out. You see, it's very dirty. You can see there. You can see the rest of the fruit, or even whole fruits. And in that particular, in the liquid only, we obtain 91% of reduction of the organic matter. So it's quite a very large reduction in the liquid. So we are not counting the solid there. Okay, and this is the material I mentioned we were using,
Yeah.
So these bamboo type things. So imagine that this is some ceramic that we use there,
As
So
the fuel cell.
yeah. So the carcass, the body of the fuel cell can be done with this ceramic thing, or even with this bamboo. But if you compare with our system, which is, you see, shiny and nice, etc., but you cannot put that in the field.
Yeah. So this would be how you would do it in a lab here with this.
This is what we do in the lab, and you can see you can see the light. That LED flashing, right? Now, yeah. So you can see it flashing every few seconds. This is the electricity produced by the fuel cell.
Okay.
The microfusion. Yeah. So that is what you. So the idea was that slide summarizes everything: the wastewater, the micro community, the system, and you get a bit of electricity and clean liquid. So this is what we are doing. Yeah. Okay, it's not very impressive. You see only a flash of light, but imagine that you can harvest that electricity and you can put it in a larger city.
Yeah.
It can be done. It can be done. That's what I want to say.
And do you think, in terms of for so long, coffee has just been just a drink, hasn't it? But there are so many different things that could be done with a lot of the byproducts and a lot of the extraction of the certain molecules. Do you think we're making the most of or getting the most out of coffee? What else could be done with it?
We expect that. I mean, I don't have it in mind, but I know there's a very, very long list of different compounds that are present there. Some of them are very simple and not very important. Some others have biological activity, including caffeine. So there are lipids, there are oils that are very, very important. There are small molecules that can be used for different purposes. That's what we would like to extract from our coffee waste. So yeah, that's what we will be doing. Interestingly, I've been contacted by people doing similar work, not similar work, trying to treat other waste, other type of waste. I mean, banana, for banana production. So we are going to test a similar approach for the banana waste.
Okay.
Now, in coffee farms, you can see all the plants, right, and banana plants among the coffee plants, and that is because they use it as to protect the coffee plants.
Yeah.
So we can use that banana. We can use coffee waste and the banana waste, and well, we will make a more comprehensive application of the system to the waste. But this hasn't started yet. So.
And where do you see all this going, or where would you like it to go? When you first started off, with the idea, and you have made that a reality, and then you're going to do some more work in July. Where would you like to see this end up? What's the end?
Well, I okay. Personally, I would like to create a system that can be used by people that really need it, right? So the social aspect of the thing is important to me. I believe it's something that it will train people there. It will give some autonomy. It will give some way of self organizing and self sustaining the farms, right? Professionally, I would like to have a system up and running that's showing that you can produce electricity, you can clean the water. That from the professional point of view or scientific point of view. Importantly, I think at the moment we need to consider all the environmental issues that are that consumption of this food stuff and things are causing to the world, so to the planet. So I believe that if we can design an integrated system to treat waste, it will help. It will not cure climate change, or but it will be a step in the right direction. So I think it's in terms of sustainability, in terms of self-sustained farms, production, social aspects. That's what I would like to see. This applied in a real system working well.
Yeah. And what has
I'm
been...
using a natural system, not an artificial system. Right?
Yeah. And what has the reaction been from those Colombian farmers that you've shown this to? Have they been impressed with it? Is it something that they really, there's an appetite for from them?
Yeah, I mean, people are very wise, and they know that they cannot be spoiling the water or spoiling the ground or the soil, and we had a chat with some people, and they say, well, we're trying to protect our water springs because they are not in the mains, so they don't have a pipe with water. They have to extract water from, or electricity. They are not in the grid. They have systems, individual system for the farm. So they said, well, anything we can do to help us, it will be good, That's why they offer a plot for us. They say, you want to install the system near the pool where I wash the fruits, that's fine. You can have a system. As long as we don't perturb the production, that's fine. So people are very interested in this, and I guess if we can show that we are serious and that we are not trying to con anybody, that will be good. But if we make a mistake, that we will be severely punished, I guess.
Yeah. And how did you get in touch with the farmers then? How did you sort of identify which ones you were going to approach? And
well, as far as I know, I'm not from Colombia, but as far as I know, the coffee farmers are very well organized in cooperatives and groups, local groups, regional groups. And my colleague in Colombia, Lina, she was in contact with farmers there. She went to them. She explained what we were doing. She said that we would be interested in working in collaboration, and yeah, they were very open to us. And I visited there. We had meetings. We explained what we wanted to do, and they are very open. And yeah, I think they can read very well if your intentions are good or not.
Yeah.
I'm sure. So yeah, yeah, we were in contact with several people there and with a cooperative, and they were very open, including a very large farm that I think they were the largest farm in the region, and they were also interested in joining our efforts. So yeah.
Excellent. I really enjoyed talking to you today, Professor Avignone-Rossa. Thank you so much for your time. I'm wondering if anyone else has any questions. We've had a few in from our audience today, but you've answered admirably all the questions that I had for you. And you did, because I was worried that obviously I'm not scientific, from a scientific background, but I think you've managed to really convey very beautifully how it does work, actually, and it was good to see some of the images on your slides as well, because that sort of gives you a real idea of what it looks like, especially with the bamboo and the ceramics as well. That's just something
that's something that we were very interested in testing. When we went there when I went to the farm initially, I said, "Oh, this is something we could explore." We have more information. I didn't have time to show this, but we have a lot of information and images. Images are very interesting. So, well, thank you for inviting me. And if there's anybody's interested in chatting with me, please feel free to contact me. Yeah, I will be interested, even just to answer questions, not to establish any particular project or something like that. But yeah, I would also be interested in chatting with people producing instant coffee, or even from roasteries or from coffee chains. That's what we are starting in October, and I believe that is going to be very interesting. So unashamedly, I'm publicizing myself. If there's anybody interested in chatting with me, please feel free to contact.
That's excellent. Thank you very much for that offer, and I'm sure there'll be some who take you up on that. From the University of Surrey, Professor Claudio Avignone-Rossa, thank you so much for speaking to the British Coffee Association today, and we look forward to hearing more about your research come October, and we hope that you have a good trip in July.
Okay, thank you.
And yeah, if there is anything else that anyone would like to ask, either through ourselves, the British Coffee Association, or they can get in touch with Professor Avignone-Rossa at another time. But for now, I think we will wrap that up just a wee bit before 1 o'clock. But thank you so much, Professor, for your time, and thank you for
thank you for the invitation.
Thank you. We look forward to speaking to you again at some point. Thank you very much.
Excellent.
We'll enjoy
Thank you.
We'll put it up on YouTube later as well for you to access.
All right, brilliant. Thank you.
Thank you very much. And that's it. Goodbye from us.